In these videos, we are going to consider transformations of quadratic functions, and the transformation we'll be considering here are reflections and translation. Okay, so and the results we are going to obtain will be from parent function. So we consider this. We have y equals x squared. This is from parent function of quadratic. So we consider y to be x squared plus 2, y equals x squared minus 2. So let's start from these three. Now from parent function, we have y equals x squared. This is the graph for that. Okay, this is for y equals x squared. Now for y equals x squared plus 2, y equals x squared plus 2, that means you are going to have this will move up 2 units. Okay, and we now have this to be here. This is for y equals x squared plus 2. Okay, this is 1, 2. Then for y equals x squared minus 2, this should move down 2 units. Okay, so this is 1, 2. So this is for, you can see the first one, we obtained x squared plus 2 and x squared minus 2 from parent function. So the second question here, you have x squared plus 2. Plus 2 implies there is translation, and the translation here is vertical shift. That means the graph will move up above x-axis, 2 units above x-axis. Then for x squared minus 2, that one is also translation, meaning that it is 2 units below x-axis. Okay, so let's consider what's it called, horizontal shifts now. So suppose we are, by considering these examples down, you have y equals x plus 2 squared. So what you have here is what we call horizontal shift, and plus 2 here implies that you will move this to what, 2 units to the left. That's the meaning 1, 2. Okay, so that means the graph will be here. Here is it. Okay, then x minus 2 squared, that implies that 2 units to the right. So whenever you have minus inside brackets like that, so that means it is going to the right. Okay, and that's what we call vertical shift. When it is plus 2 or plus any constants, that will move to the what, to the left, and it's also called vertical shift. Okay, so this is here. Okay, good. So that's for transformation of quadratic function, both for vertical shifts and horizontal shifts. So the examples we consider here are called vertical shifts, while these last two examples are horizontal shifts. Okay, so let's consider examples that combine the two together. Suppose you have something like this. So these two examples now, this is combination of both vertical shift and horizontal shift. So 2 here is horizontal shift, and plus 2 implies that 2 units to the left. Plus 3 here is vertical shift, and that is 3 units above x-axis. While the second question here, where you have x minus 2, minus 2 here implies 2 units to the right, and 3 here implies 3 units above x-axis. Okay, so to obtain this, we are going to have something like this. Okay, let's call this to be, this is minus 1, minus 2, minus 3. Okay, and here so we have 1, 2, 3. Okay, 1, 2, 3. Now since this is plus 2, don't forget I told you that this will move towards 2 units to the left. So this is 2, then 3 units above, that means the graph must be here. Okay, so which implies that the vertex of that particular function, of that given function now, is at minus 2 comma what, minus 2 comma 3, and here is the graph of that function. Okay, so for the other one where we have y equals x minus 2 plus 3, So this is 2 units to the right and 3 units above x-axis. So for that we have, so this is 1 2, okay, 1 2 3. So don't forget the vertex here is what is 2, 3. So here is the vertex, and this is for what? This is the graph of that function. So the examples we've been considering so far are under reflection, are under transformation, and are under translation. And the translation we are considering here are vertical shift and horizontal shift. Okay, now we are going to consider both transformation, translation, and what are reflection. Okay, so reflection is just that when you have y, if y equals to f of x, so this can be written as minus f of x. So this is what we call reflection on x-axis. So we have two different reflection on x-axis and reflection on y-axis, but this is called reflection on y-axis. So for quadratic function, remember I told you the parabola can only be in two forms. So it can be something like this or this. So the parabola will opens up or opens down. So it can be of these two forms. So for you to have something like this implies that a must be negative. That's the meaning. A must be positive. A must be positive. So when the coefficient of x squared is greater than 0, you have something like this. And when a is negative, so you have something like this. Okay, so let's just consider two examples on this. Okay, suppose we have, okay, from this we have minus x squared. For minus x squared now we have this. It's just like reflection on x-axis for y equals x squared. So we have something like this for that. Okay, so this is for y equals minus x squared. Then for minus x squared plus 2, remember plus 2 here implies that 2 units above x-axis. So the graph will move up 2 units above x-axis. So you have 1 and you have 2. Okay, so because you have negative here, which is minus x squared, that means what you are going to have here face down. Okay, this opens down. Okay, so this is for this. Then for minus x squared minus 2, what that means is that is 2 units below x-axis. 1 2. Okay, and of course minus x squared implies that the parabola will face down. So you have something like this here as well. Okay, so these are the examples of transformations of quadratic function, both for reflections and translations. Okay, then now last example on this. So let's consider a function that combines what's it called, reflection, translation, and the translation must be both what's it called, vertical shifts and horizontal shifts. Okay, suppose you have y equals minus x plus 3 squared minus 2. Okay, so let's see something like this down. So when you look at this, we have horizontal shifts of 3, and because you have plus 3 here, that means 3 units to the left. Okay, and minus 2 here, we have vertical shifts is 2, and because of minus 2 now, that is 2 units below x-axis. Okay, and remember y equals minus f of x is a what? Reflection of y equals f of x. So, and this reflection is on where? On x-axis. So these are the three important things we need to consider here for us to sketch this given function. Okay, so by implication we have this Okay, so let's start with horizontal shifts. 1, 2, 3. Okay, because it's 3 units to the left. Then minus 2 here, which is horizontal shift, 2 units down. 1, 2. So which implies that the vertex of that given function now is here. So here is the vertex. Now because you have minus here now, so that means it opens down. Okay, so and we have something like this. So this is the graph of that function. Okay, so where the vertex here is minus 3 comma minus 2. So that is the vertex. Okay, if you are just joining us for the first time, kindly click on the subscription bell so that you'll be notified whenever I release another video. Thank you. Bye.